Hello, welcome to Chingster's video on quadratic functions. In this video, you will learn about the different forms of quadratic functions and how to graph quadratic functions using key features. There are three forms of a quadratic function. The general form would be f of x is equals to ax squared plus bx plus c. In all forms of parameters, all the coefficients are real numbers and a cannot be equal to 0. The next form will be our vertex form. So f of x is equals to a times x minus h squared plus k. So if we want to look at the general form a, when a is positive and when a is negative, so you can see that when a is positive, okay, it's like a smiley curve, and when a is negative, it's like a set curve. So when a is positive, this is a minimum, and when a is negative, this is a maximum. Very often we want to transform the general form of the quadratic equation to the vertex form. Do you remember how we can do that? Yes, the method is by completing the square. So let's look at some examples on completing the square. So for example, if we have x squared plus 4x minus 1, so when you complete the square, you want to express it in the vertex form. So x squared plus 4x minus 1, you have to convert it to ax minus h squared plus k. So in this case, I want to first write it as a bracket. So x, and bring down the plus sign, plus, and 4 over 2 and square. So when you expand, this becomes x plus 2 squared. Now when you expand x plus 2 squared, you end up with x squared plus 4x plus 4. There is an extra term of plus 4 here. So what I do in my original expression, I must subtract the 4 to keep it equivalent to the original equation or expression. So from here, when I complete the square, I will get x plus 2 squared minus 5. So this is the vertex form of a quadratic equation. I have transformed from general form to the vertex form by completing the square. Let's look at another example. What happens when a is not equals to 1? For example, if I have negative 2x squared, let's say plus 10x plus 2. So in this case, there are two ways you can do this. One way is to factorize out the negative 2 from all the three terms, or for me, I'm just going to factorize out the negative 2 from the first two terms. So when you factorize out the negative 2, you end up with x squared minus 5x and then plus 2 here. Now I'm ready to complete the square. So negative 2, this is x minus 5 over 2, the whole thing square. And remember, when you expand x minus 5 over 2 squared, you're going to end up with x squared minus 5x plus 25 over 4. So in this case, I have to subtract 25 over 4 from this expression here. And then I keep the plus 2 from the original expression. And the next part, I will multiply negative 2 to every term. So negative 2 times x minus 5 over 2 squared. And then I will multiply it by 2, so I get plus 25 over 2 plus 2. Now I can combine the constants at the back, so it's negative 2x minus 5 over 2 square, I forgot square, 25 over 2 plus 2, this is, I multiply by 2 here, is so I plus 29 over 4. So this is the vertex form. Now I would like you to think about how you can try to transform the general form to the vertex form using A, B, and C. Now remember to pause the video to give yourself some time to work through problems or think it through before checking your solution with mine. So if I look at f of x is equals to ax squared plus bx plus c. If I want to factorize out the a, so it's x squared plus b over a x plus c. So I end up with a, and then I divide, don't forget your big bracket, and then I divide by 2 plus b over 2a square, and I have to subtract b square over 4a square, and then I plus c here. And then I multiply a to every term here. So ax plus b over 2a square minus b square over 4a plus c. Okay, and then from here I can combine the two constant terms. So this over 4a, so is minus b squared over 4ac over 4a. As you can see, this is the vertex form. And we're going to use this later on to fill in our information about the vertex and axis of symmetry. And from here, I'm going to fill up the intercept form. We have f of x is equals to a times x minus p times x minus q, okay? So I'm going to now fill in more information about our vertices. So if you look at the general form, the axis of symmetry will be where your x plus b over 2 square equals to 0. If you look at this, this will give us the axis of symmetry. So it will be, the answer is x minus x equals to negative b over 2a, and the vertex will be negative b over 2a, and the y value, oh, I made a mistake in my completing the square earlier. This should be a plus, so I should rewrite this as a x minus a x plus b over 2a squared plus 4ac minus b squared over 4a. We can write this as the, so as the 0.4ac minus b squared over 4a. Okay, another easier way, you don't have to memorize this expression, you can just write it as negative b over 2, and then f of negative b over 2 as your y value, for your y value. And the y-intercept here will be is equal to c. For the vertex form, is rather straightforward. So the axis of symmetry is when your x minus h equals to 0. So your x equals to h is your axis of symmetry. The vertex is when your x is equals to h. And when you substitute h here, you get 0 on the first part. And then k is your y value. And for intercept forms or the factorized form, the x-intercept is when the whole expression is equal to 0. So you get your p and your q as your x-intercept. The axis of symmetry, what do you think it is? If you have the p and q, so the axis of symmetry would be the midpoint of p and q. So it will be x is equals to p plus q divided by 2. Vertex would be where is p plus q divided by 2, and of course is f of p plus q divided by 2. When answering questions, you may be asked to sketch on paper the graph of a quadratic function. You could do this by plotting the graph on your GDC and then carefully recreating the sketch of the graph on paper. Or sometimes you just have to remember the key features and sketch it out. A sketch should show the general shape of the graph accurately. Label the key features, including the x and y coordinates, the coordinates of the vertex, and the equation of the axis of symmetry. So the last one is depending on the question. If they ask you, then you can put. Usually we don't label unless we are asked to. We have gone over the big ideas, so let's look at some examples. In this example, write down the coordinates of the vertex and the equation of the axis of symmetry for each function. So I would like you to pause the video and work it out on your own first before checking your answers with mine. As you can see, these two equations are in vertex form, which is f of x equals to ax minus h squared plus k. From here, the vertex is equals to h comma k. And I can apply that, so the vertex for this will be 4, 1, and the axis of symmetry is when x is equals to 4. So this graph actually looks like this. I'm going to draw it here, sketch it here. Vertex is, you can try sketching on your own first before comparing your answer with mine. 4, 1, this is the vertex. This is a negative, so this is a set curve. The y-intercept will be when x is 0. So the y-intercept will be, so f of 0 would be -3 and then -4 squared plus 1. So -3 times 16 plus 1. -3 times 16 would be -48 plus 1, -47. So it's something, it's going to look like that. All right, so this, you can label the vertex and the intercepts. Okay, for part B, f of x is equals to 2 times x plus 3 squared minus 6. So here the vertex is -3 and -6, and the axis of symmetry will be x is equals to -3. For this function, a is positive, so this will be a minimum point, okay? And the parabola, you can see that is it concave up or concave down? We will call this concave up, and this is what we call concave down. In example 3, state the concavity of the function y is equals to -2x squared plus 4x plus 1, and find the equation of the axis of symmetry, the vertex, the domain and range, and vertex of the quadratic formula. I would like you to pause the video and try on your own first and see whether you're able to apply the concepts. So when we look at the concavity, so look at the a value. So we know that in this case, the value of a is negative. So this will be a set curve. So this function is concave down. And to find the axis of symmetry, so we know that x is equals to -b over 2a. So in this case, b is 4 and 2 times -2. So the axis of symmetry will be x equals to 1. Next, the vertex. So in order to find the y value for the vertex, I will substitute in 1. So f of 1 will be -2 times 1 squared plus 4 times 1 plus 1. And you end up with -2 plus 4 plus 1, and that is equal to 3. So your vertex will be at 1, 3. And the domain and range, you can look at it visually to kind of like help you. So this is if I look at this function, the vertex is 1, 3, and it is, the y-intercept is 1, so it's something, it goes like that. Okay, so you can see that the domain will be all real numbers, and the range will be, your y is greater than, this is actually 1, 3, so y is less than or equals to 3. And now I want you to find the vertex form of the quadratic formula. It should be quadratic function. Okay, and so you want to practice completing the square. So y is equals to negative 2x squared plus 4x plus 1. I'm going to factorize out negative 2. So I end up with x squared minus 2x plus 1. And I keep the negative 2 outside, and I write it as x minus negative 2 divided by 2 is 1 squared, and I have to subtract 1 because I'll end up with the extra term of 1. So negative 2 x minus 1 squared plus 2 plus 1. So I'll end up with negative 2 x minus 1 squared plus 3. This is our vertex form. In example 5, we have to find the equation of the quadratic function whose graph is a parabola. So in this case, you can see that the intercepts are given to you. So we can write it as f of x is equals to ax minus p, and then x minus q. This is the intercept form. And I know that negative 3 is one of the points, so I write it as x plus 3 and then x minus 1. My job now is to solve for a. So I'm going to use another point on the curve, which is 0 and negative 6. So negative 6 is equals to a times 3 times negative 1. And I end up with negative 6 equals to negative 3. A is equals to 2. So in this case, my function will be equals to 2, x plus 3, and x minus 1. In case you're wondering what the word parabola means, it actually means like a U-shaped curve. We've reached the end of our video on quadratic functions. Thank you for watching. Don't forget to keep practicing with those extra examples given in your notes. Goodbye.